I've been looking all over for you, you little robot. Well, good day, everyone. I find you once again tuning in. How lovely. But anyhow, before we get into the nitty-gritty of things, we have a special day ahead of us. For you see, we have a guest tuning in. So, if you will, come on, follow me. I'll, see you over there in a few seconds. Got it? Good. And hello once again, everyone. Here we are, just a few seconds later, and I have with me today one of my greatest scientific friends here, Miss Julie Baile. She is an Earth and Environmental teacher at Newbridge Middle School. Yes, say hello. Say hello, Miss Baile.
Hello, everybody. I am thrilled to be here in such a high scientific community.
Oh, yes, very much so. Well, me and Jambot today, we have a pressing issue to discuss, as I have just said. Today, we are talking about the next step in human exploration, life on Mars, to be exact. Now, I'm sure you've heard of all this news about NASA and SpaceX talking about how they're going to achieve the coveted Mars mission. Yes.
Yes.
But we're here to talk today about how we are going to achieve said goals. Now, I'm sure many of you remember my entry about Mars just a few episodes ago. And I talked about that even though Mars acts as a sister planet to Earth, there are stark differences, quite frankly. And I have with me my friend today to talk about those hurdles that we have to conquer. Now, Miss Baile, I ask you, what are the problems that astronauts have to conquer?
Well, the first one would be a simple life process of breathing. Mars is probably 70% carbon dioxide, mostly made of carbon dioxide, a lot of it, and so the atmosphere is very thin. Remember, we breathe out carbon dioxide and we breathe in oxygen. So having an oxygen supply and the right atmosphere to sustain life on Mars is the first big hurdle. First one.
Right.
And having enough oxygen in a space capsule. If it is a time where they're living on the space capsule, you have to continue to create that oxygen. So that's one. Another would be the temperature. It's minus 70 degrees Fahrenheit on Mars because the atmosphere is so thin. So that space capsule and the clothing, if you're outside and about, has to be warm enough and insulated because it's minus 70 degrees Fahrenheit to keep you warm in the correct temperature. So those are two things that we will absolutely have to take into consideration when we're there. Life processes of living and staying warm and breathing.
Right. And those are two very, very big problems that many astronauts have to work out, so to say.
There's a third one, though.
Three. Oh, good.
Water. There is no water. It is a terrestrial rocky planet. So its land, the amount of land it has is the same as Earth, even though it's smaller, because Mars has no water. And as you know, humans need water. So however long we are there, we need to have an adequate water supply. And we can't get it outside. So water would be another one.
Right. Now, many of you might recall that scientists have technically found water on Mars on the poles. But the problem is, all this water is buried deep beneath the surface, and it's not liquid water. It
Right.
is solid water, that ice.
And there's
That
evidence that there was water billions of years ago. Liquid
Mm-hmm.
water. Still no help today. So you're right.
Right, right. Well, those are quite some stark issues to take on, but fortunately at this time, research facilities have worked on solutions regarding these problems. And one of these solutions regards exploration of the planet itself. Now, I'm sure many of you have heard about the several rovers that are on the surface of Mars right now. There are 4 right now, as a matter of fact. NASA has sent Sojourner, Spirit, Opportunity, and Curiosity. Right. Those are 4 rovers, and they conduct research, like they take samples of the soil and see what Mars is made of. They take samples of the atmosphere, see what it's made of. So really, these rovers are quite integral in seeing what the planet is made of before we go there one day. Now, in terms of current events, NASA has launched a program called InSight. And this program involves a single geophysical lander rover to study the planet's interior. Now, if I can recall, this rover touched ground about less than 2 years ago. Viewers, you might want to look me up on that fact. But if my mind's eye is true, that should be correct. And NASA has plans to send yet another rover in the coming decade, the 2020s. But anyhow, that is the top level as far as exploration goes. But like Miss Baile said before, we need to focus on life support systems. Isn't that right, Jambot? Fortunately, you don't have to have a life support system because you are a robot. But we organic humans need something a bit more complicated. Now, 3 concepts of the life support system are environmental monitoring, atmosphere management, and water management. And I have with me my notepad, and I don't know if you can see it, but I made a simple schematic of really a modern life support system. So as you can see, where Jambot is, that's where essentially the human is. And humidity in the system goes out, and it goes into the waste system, which is converted into brine, which is converted into cabin water vapor, which that water vapor can be used for actual drinking water if it's sent through a purifier. Now, like Miss Baile said, we breathe out carbon dioxide, you might recall. So that life support system has to have a CO, or carbon dioxide remover, which goes through a reduction phase, which goes through another phase that sort of converts it into acetylene. Acetylene, is that right? I think so. Yes, that all that life support system mess or whatever. Now, and this water system, it also provides astronauts with oxygen. And so oxygen comes back into the systems, thus making it a continuous cycle of gases and liquids and all of the main parts of life support. And of course, we have to talk about the subject of actually going to Mars itself. There are many companies working on vessels to travel to Mars, but one of them that has caught my eye is SpaceX. And right now they're working on a plan called the Atlas V-541 rocket. And I have another little sketch here, as you can see. There we go. So down below, we have your the actual Atlas 5. Actually, that V is supposed to be a 5. I'm sorry about that. The Atlas 5 rocket is right down there, and that is basically a throwaway part of the rocket. Like, it's different from a space shuttle, you see. For rockets are meant to be a single-use type of vessel. Is that right?
Multi-stage.
Multi-stage. Yes. And you have, just beside the Atlas V rocket, more solid rocket motors, which will further propel the rocket in its journey. And up here you have another cabin, which is called the Centaur. This is the stage 2 phase of the rocket itself. And just beside that you have the payload fairing. Well, the specific thing about this rocket that makes it so great for space travel, so to say, is that it has the adequate amount of liftoff capability and weight requirements. Those two things are going to be integral in any type of space travel. Now, as far as actually living on Mars, there we hit kind of a roadblock at the moment. For as far as the cabins on Mars go, they are still in development. But with all that aside, and of all the things that I have talked about, and Ms. Baile has talked about, the main thing that we need to know is that to get to Mars, we have to get to the moon. Now, I'm sure many of you have learned about the legendary moon missions back in the late 1960s and early 1970s. Right? Have we learned that in history class? I know Jambot has. I taught him myself. Now, NASA actually aims to send 2 astronauts near the South Pole by the year 2024, which is a large feat, but I believe it's possible. And as far as colonies on the moon go, we hope to have these set up during the 2030s. And this is actually called the Artemis program. Several of you Greek mythology nerds out there might know about Artemis and how really a lot of space things are connected to Greek mythology. But anyhow, until then, we can only dream about the many adventures that we will have in the great beyond and in the grasps of Mars. Anything to add, Miss Baile?
It's exciting to be a scientist right now. So much to look forward to.
That couldn't be further from the truth. Well, I do believe we are drawing to a close for now. So, as I bid my viewers farewell, I bid you farewell, Miss Baile. I appreciate you joining us today.
It was my pleasure. Thank you very much.
No problem at all. Ta-ta! One moment. Oh, wasn't that lovely, Jambot, to have her visit on us? I certainly think it was. And I would like to thank you once again for tuning in to my little series. If you have any questions about space and whatnot, feel free to leave them in the comments section. Who knows, your question might be featured on the next video. And with that, my friends, like I bidded farewell to our guest, I bid farewell to you. In 3, 2, 1...